So we've had a question asked and a special request for a video made about making estimates using derivatives. Where is this relevant? How about assignment 3.1 parts 1 and 2? In particular, 3.1 part 2 number 4. I guarantee you that this question is asking you to make an estimate using a derivative. So let's look at a picture. Here's my generic function. It's just some function. This is its graph. It makes this picture. Okay? If I say I want to look at this number right here on the x-axis, let's call it, normally I would call it, n, but you don't like that because you're a student, so I'll just call it 2. In either case, it's just some symbol. But right here, when x is 2, I can find the derivative of f. If I found the derivative of f, here's the derivative of f. If I evaluate it at 2, then I will get the slope of this line, the tangent line. So the slope of that line is f prime of 2. Okay? And the value that I'm getting on the y-axis right here, that's the number f of 2. It's just some y value. Now the derivative, the equation of the tangent line is the equation of the tangent line is a very close approximation to the curve near its point of tangency. You can see that this red line gets further and further from f the further away we get from this point. But very close to this point, it's a good approximation. I wonder how good of an approximation it would be if I just moved over by 1 to 3. Let's look. There's 2 things happening here at 3. I'd have the point that's on my tangent line, and I'd have the right triangle that can get formed right there. Since all I did was move over by 1 to get to 3, then that makes my run be 1. What would my rise be? What would my rise be? Well, the slope of this line is m. It's f prime of 2. And slope must be rise over run. And if the run is just 1, then you can see that the slope, which is f prime of 2, is the same thing as the rise, because the rise over 1 is just the rise. So that makes this rise right here be f prime of 2. Now you can see that that red dot that we get right here is not quite on the curve f. that y value is f of 3. Right? You put in the 3 and you get this y value. They are different by this much, but it's not that much different. And the length of this little red line right here, this vertical red line, has a length of f of 2. And it is very close to the actual change that we're seeing between, excuse me, I misspoke. The length of that little red line is f prime of 2, and it's very close to the difference between f of 3 and f of 2. This distance right here is exactly f of 3 minus f of 2. And it is approximately the same as f prime of 2. It only differs by that little amount right there. It is this equation that people need to understand. I haven't talked a thing at all about revenue functions or whatever. I haven't talked about average revenue, nothing. I'm just talking about a function f. And this is what happens if I take its derivative. All it's saying is that it is a close approximation to the underlying function nearby where it is tangent. Now, there was nothing special here about 2 and 3. I could change this, if that was 2, then this would just be 2 plus 1. Okay. 3 would just be 2 plus 1. But there's nothing special about 2. I could go through here and change all the 2's to just n. And it's the exact same picture. And what we've uncovered here is that if I take the derivative, evaluate it at n, and then just move over by 1 unit, I can estimate how far I have to go vertically to get back to the curve. Well, now you can change your f to be a revenue function. If I have a revenue function and I were to take its margin and evaluate it at n, then it would be approximately the difference between r of n plus 1 and r of n. And they like to rearrange this so that it says r of n plus 1 is approximately r of n plus r prime of n. Nothing special happening here. It shows up in this picture just the same. What would that rearrangement be? It would just say that f of n plus 1, f of n plus 1, which is this number, f of n plus 1 is approximately f of n plus f prime of n. I'm going to draw it in yellow, some lines for you. This length is f of n. This length is f prime of n. When you add them together, we're nearly to f of n plus 1. So it is approximate. And we like to use these to make estimates. Being a revenue function, or being an average revenue function, or being a profit function, or being a cost function, or an average cost function, none of that really matters. It's just a function that behaves this way. So in addition to the revenue function doing this, the average revenue function would do this. Any function would do this. Okay, so here's an example problem. Let's see. I'll have a revenue function which is we'll just make it be x squared minus 1. That, I guess, is fine. So there's my revenue function, and I'm supposed to actually, let me say I want to do this. There's my revenue function, and let us estimate the average revenue when x is, who knows, 10. Then I'm going to end up using the fact that the average revenue function at 10 should be equal to, or excuse me, should be approximately the average revenue function at 9 plus the marginal average revenue function at 9. This is what I'm looking for. This is what it's approximately equal to. So this is my estimate over here. Then all I need is the average revenue function and its derivative. So the average revenue function would be x squared minus 1. I've just divided everything by x. The marginal average revenue function would be 2x. So then, the estimate of the average revenue for 10 units would be nine squared minus 1 plus 2 times 9. And I would get 81 minus 1 plus 18. So 98. That's my estimate. what it would really be, our average of 10 really is 99. It'd be 10 squared minus 1. So it's very close. In some of the problems on part 1 of assignment 3.1, they want you to estimate the total revenue when it's 10 units. Well, if I want to estimate the total revenue via the average revenue estimate, then I would simply need to realize that X times the average revenue is the same thing as R of X. They're equal. And that's because the average revenue is exactly R of X over X. And if the X's cancel, you have R of X. So then, using my estimate of what I get at 10, that I get 98, then I would estimate that R of 10 would be 980. What is it actually? It actually is 10 cubed minus 10. So it's not exact. I don't exactly get 990 for my estimate, but I got 980, which is really close. And that's how we do this estimate game.